Hey there everyone, all the techies and data enthusiasts there. So guys, welcome back to my YouTube channel. In today's video, we are going to discuss about Llama 3.2 model, which is officially out recently. So I'll be showing you all the different ways to access the model. And apart from that, even I'll show you all how you can fine tune the model using Unsloth. So this video is going to be definitely interesting. You will be learning how to fine tune with the Unsloth, where you don't even require any GPUs. You can do it with your free collab version itself with a normal CPU. That's the main advantage. And you have some free T4 GPUs, right? That is enough, mostly enough in collab, which you are having to fine tune the model and get the results without dropping the accuracy. So that fine tuning part will definitely be very interesting. So now let's dive into my computer screen and discuss about Llama 3.2 model and its variants and its benchmark, and then finally we'll start with fine tuning. So guys, now let's get started. Before that, if you have not subscribed the channel, do subscribe the channel and on the bell notification. So guys, here you all can see this is llama.com page where you have introduction to Llama 3.2 model, a open source model which is fine-tuned and distill and deploy it anywhere. That's one of the main advantage. So there are many of the things out now. Even there is something called Llama Stack which is out. So I'll just give an overview here, but a new separate video will be created on Llama Stack and its implementation. It's going to be very interesting. So you can download 1B model, 3B model. These are light models, and 11B, 90B. And if you want to continue, then you have, I guess, 405B model as well. So here, yeah, 405B flagship model. If you want, you can even download this as well. So you can see it's already mentioned here, lightweighted models where you can run it anywhere or everywhere, including your mobile and the edge devices as well. That is one of the main advantage of this 1B and 3B model. When it comes to multi-model, these are 11B and 90B models, which is flexible, and you can even reason on high resolutional images as well. So you can get reason on it. So you can download these models here. So for that, you have to fill this form to get the access. And let me just fill it now. That's okay, I got access for it, so it's not a big deal. And you can now see here, so once you have these models, you can download them. I'll show you how to use them as well. So on device, you can see here, you can use 1B and all those models. Here you have the details about it, so how it is working on, there is a video on it. And if you just click here on learn more, you will understand how to use it. So you have a GitHub link here. For now, it is only available for iOS. So very soon we will get it for Android as well. You can have a look on it. So what it is doing here, you can see here. So it's summarizing the calendar and other text related activities it can perform and align accordingly. You have even multi-model as well. So for multi-model also you have a video here. So just drag and drop the image. It's dropping the image of a nice interior designing asset. So and it got description about it. So you got description about it, whatever is in this particular image and what it's doing. So you just got information about it. And Firepiece C alternative, you can even change them if you want to change anything inside the model. So just select and click on lookup and you got it. So here you can see here, these are the different Firepieces. So you can just change that in live here. That's an advantage here. And Llama Stack. So what is Llama Stack? Even about that it is here, but Llama Stack, let us detailedly create another video as well. So there were some errors coming in between, so you will understand that once we start to create here in a separate video. So you can actually access the Llama models in your terminal itself. That is one of the main advantage. Okay. So, and this is the Llama Stack's application UI. You can say developer, Llama Stack API and CLI calls and all the models which are there and partnering with it. So this is an open source model and you have the benchmarking of it. For light version, you have the benchmarking. So you can see they have compared with Gemma 2B and Pi 3.5 Mini IT. You can see here MMLU. So MMLU, you can comparison, you have open rewrite reveal, you have TLDR 9 plus you have, and math and GSM 8K, ARC challenge and GPQA. So all this zero shot learnings and few shot learning evaluations and everything are done. So even you have evaluation benchmarks and everything. So This is for the lighter version model, and when you go to vision model, even the vision model benchmarks are here. You can see here MMLU, so you can see here 3.211B and 3.2 90B model. They have compared this with Claude 3 Haiku and GPT-4o Mini. So if you can see here, it is approximately GPT-4o Mini is still good, but when it comes to using Llama 3.2 9TB model, it has beaten GPT-4o Mini. Claude and Llama 3.11b MMU is almost same, and evaluation testing, and here also same AI2 diagram and all the other things are mentioned here. For general text processing, you can see here 73%, 86%, so 75 and 82% Claude and GPT-4 Omni. So you can see here downloads on Hugging Face. It's already 350 plus million Hugging Face downloads. So 10x growing since 2003. That's really great. And yeah, so partnership enabled for Llama 3.2. So Dell Technologies have partnered with them and some community forms here. So now I'll show you all how you can access this model. To access this model, right, you can just open Hugging Face .co/models. So in this, now here you can just search for meta and enter. So based on meta llama, so this if you open here, you can see your team members, and even you have the latest collections here, 3.2 evaluations, instructions, and even the code for it. You can just open whichever you want. So you can just open 1B model, click on use this model. You want to use it on local apps like VLM or in transformers. So using transformers, this is your code to call it. And however, you can call them using Hugging Face. This is one thing. And even you have an option to call this with Grok as well. Later, very soon, you will be having the availability in LangChain as well, I guess, to call them. So that's not a big deal. They'll be working on it. So Grok, I'll open the Grok. So yeah. So Grok Playground. Let's open Playground. So this is our Grok Playground where, okay, let me log in. Okay. So I have done have logged in. So you can just see here you have different models available here. So from the Llama 3 models, you have all this Grok preview versions, 70B and 80B preview tools to use. And here you can see Llama 3.2 11B text preview, Llama 3.2 90B text preview. All these models are available here. So you can select whichever model you want. So I'll take for now 3B model, preview model. So I'll just write here, hi, who created you, and submit. So immediately I'll get the response. I'm a computer program designed to simulate conversation AI. Okay. Or else you can even say who is your founder. It will give Meta, I guess. If I'm not wrong. Yeah, you can see here. Created by meta.ai company, so which is focusing on solving various complex problems. Okay, and even you will have your token information as well and speed insights. So Grok, right, I especially like Grok because in Grok they use neural processing units, I guess, NPUs or TPUs. They are using NPUs, they are mostly using NPUs, because of which their inferencing speed, you can say it's lightning fast. You will get the output within seconds. That is one of the main advantage. So if you want, you can give a try with Grok. It's always free and open source. You can just use any models you want. And if you want to use it in code, right, just click on this view code. You will immediately get here. You can see here, you can copy this code and let it try out from your end. And to create API keys, click on here and you can generate the API key of Grok. Any API key you want, you can just click on create and you can use it. Okay, so I already have an API key, I'm not creating it. And later, if you want more details, you can go ahead with the documentation. Okay, so I would recommend just give a try on it, how to use it. It's going to be very interesting. Okay, now let's get into the fine tuning part. So you guys understood this, right? So you can access the models either from Hugging Face directly or from Grok. So anything is of your choice. Now when it comes to fine tuning here, so here we are just directly taking the model from Hugging Face only. You don't need of Grok. So let me just connect the code to my T4. I'm using T4 for now, and actually this code is written by Unsloth only, so we are just going to test it. It's going to be very interesting actually. So I tried it, I have connected it. Let me run the cells now one by one and I'll explain you all the code as well. Okay, let me run this first code here. So the first code says that, and you can see a quick shout out to Daniel Hanchen. So he is the founder or a founding member of Unsloth, you can say. So he is very good. You can follow him on LinkedIn as well. So whatever interesting updates he has, he'll be updating there. So you have Unsloth's official address as well. So you can just open it and try out. This is an open source actually. So even they have the business version. If you want, you can go ahead and look on it on their website. But the open source version is only very fast enough and it was very good. Might be business version is more fast compared to this. So you can have a look on it. So what I'm doing here, I'm just installing Unsloth, and after installing Unsloth, I'm using the GitHub repo and installing along with that into my Google Colab. So this will take some time here to capture out here. So once this installations are done, then we can continue. So I'm using T4 here. Okay. Only the first line will take some time, then you will slowly understand the things. By that time, let's go to this. So from Unsloth, import fast language model. We are calling it import torch. Yeah, so this is done. You can see it took 53 seconds. That's okay. So after torch, what we are doing, we are calling the maximum sequence length of 2048. So this is auto rope scale internally has been used here. Okay. Data type is none. So we let it to be auto detection, and loading the 4-bit model. So it's true because we are loading the quantized model, reduced model. So which is 4x faster for downloading and easy to use. So you can see here already there are some models defined here, 3.1 and 4-bit 405B model also there. So we are using Llama 3.2 model, latest version here, you can see here. So let me run this code here. So Unsloth will patch your computer to enable 2x faster free fine tuning. You can see here. So the details are coming here and it's downloading the model here, 2.24 GB model, 2.24 GB. Okay. Let this to be completed, and after that we have, it's a kind of, so if you have watched my previous fine tuning video, right, using Unsloth for Llama 3.1, it's a kind of similar, but here we are using 3.2 and there are some small changes, that's all. So from fast language model, right, we are getting the PEFT model. We are importing get PEFT model function we are calling, and inside that we are defining the model. R is equals to 16, 8, 16, 32, 64, 128. You can give anything. Target module is grade project, up project, down, O project. So these all are the target modules. LoRa alpha value is 16 and LoRa dropouts we have given as 0 to optimize, and bias is none. Use gradient checking point that we can give either true or Unsloth, it is same. Okay, you can even give it as true. And random state is equals to 3407. And use RS LoRa, which is rank stabilizer LoRa. We are not using that because it will take more time. So we have enabled that as false. and loft queue config as none, and let's run this. You can see here Unsloth 2024.9 post 3 patch 28 layers are there, and we are using 28 QKV layers and 28 O layers and 28 multi-layer perceptron. So this is very clear information here for your understanding. And after this, we are getting the chat templates here. So chat template, right? We are using the same 3.1 chat template. So for 3.2 and 1, it is same only. So we are using this, and we have created the generate get chat template. So this is just a chat template we have enabled, and data set, right? We are downloading here. You can see here from Melbourne Finetuning 100K data set. We are downloading this. So this is done. And now from Unsloth.chat template, import standardized share GPT and dataset. We already have dataset, right? That we are calling here. Dataset.map format prompt and batch is equals to true. So we have enabled this. And dataset 5 conversations. So we are just taking out the fifth conversation from this. You can give anything here. It's not a problem. You can even change this name to 4 and run this. You will get it. You can see here. Print the reverse of a string using the for loop. So about that, there is a detailed content and examples and code here. So about 5, you can see here data set of 5. So you'll get now different ones. Okay, so these are just, we are checking this one, nothing else, the text we are seeing here. And now we are using SSFT, which is nothing but supervised fine tuning trainer. So from TRL, we are importing this. And transformers, we are also importing training augmentation data collection for sequence to sequence model. From Unsloth is bfloat 16 supported. We are enabling this. And code about it. So trainer variable we have created. So SFT trainer we have called. Model we have already defined. Tokenizer is defined at the already. Dataset and default text field is text. And maximum sequence length we have already defined at the first, right? That sequence length. And data collector, so tokenizer is equal to tokenizer. Dataset number of procs 2 and packing is false. So can make training 5x faster for short sequences. So if you have short sequences, you have to give it false, or else you can enable true. Training augmentation per device, train batch size 2, gradient accumulation steps 4, and warm up steps 5. Maximum steps we have given 60 epochs, 60 iterations, and 1 epoch we are giving it for full training. Learning rate is 2E4. FP16 not in bit force supported, so we have enabled this, and then log in steps is equals to 1. Optimizer, we are using Adam weight 8-bit optimizer. Weight DK 0.01. So linear and seed out. So everything, the code is automatically written here. These are some of the functions, or you can some of the variables which we need to define for trainer, or else it doesn't work. So let this mapping and installation complete. Then we have chat template. We have only train on response only option. So we are calling that train on response only, and we are mapping that again here. So once this runs, this will run. And after that, we have the code. Actually, this code is a bit more interesting. So it's taking bit time here because of the training speed. So we are just using T4, right? So I have an premium version, but I don't want to use it because if fast training completes, you guys don't understand. You guys might tell later that no, you have used the premium collab version, not the free version. That's the reason I'm not using it. So let this to complete. Let's wait for it. Okay, it took approximately 3 minutes to complete this. Okay. So, and after this, we are running the chat template to train on response only from Unsloth.chat template. We are importing train on response only, and the train on response only also we have enabled here, right? Somewhere, yeah. Adapt we have enabled it. So we are calling it again. So train on response only, trainer and instruction part, start head ID and users and end head ID and slash in. So we are just giving it a kind of format here. So nothing else for training. Now we are checking once we are verify. After this is done, we will verify once that whether the masking is done or not. Begin of text, start head ID, system, end head ID and content of it. Okay. Okay, so that's done. Now let us verify this input IDs. And after this, we have spaces of the token. So we have to even check the spaces, right? So we are checking the spaces as well. Okay. And after this, we can run this code. There is a code hidden in this related. It's just a simple code to check the memory. So you can see here, Tesla T4 we are using max memory is equals to, and the reserved is 2.635 GB of memory. So now let us start training here. So the training will take some time, 60 iterations, right? Only one epoch, but it is 60 iterations, so it will take some time. And number of trainable parameters you can see here, 24, 313, 856. Okay, so let it to train here. Once the training is done, we can perform the testing with giving the questions to it. Okay, let this training to complete. So I'll just pause till then. Okay. So the accuracy keeps on changing. So first iteration is already done. Second iteration, it continues. I'll just pause so the video length doesn't go up. Okay, guys. So it took approximately 8 minutes for me to get this fine tuned. Okay. So all the iterations are done. You can see here. All sometimes the accuracy is 98, 94. All things are there. Let us see the final once after running this. Let us see the timestamps and everything. You can see still you have the timestamps here. So what is the max memory usage and reserved memory and how much GB is still left out. So it took 7 minutes 94 seconds. Okay. And 476.622 seconds used for training. Okay. So it's interesting, right? So after this, we have directly chatting with the model. So chat with Llama 3.1, get chat template, and we are talking with it. So 3.1, why it's mentioned, I already told you earlier. So the chat template is same. It's not changed. So that's the reason. And the question is already available here. You can see here. And the input tokens, token dot apply chat template and message tokenize is equals to true, add generation prompt true, and return tensor is equals to pt. Okay. To CUDA. Okay. So let's run this. You can see here it's completing the inference. You can see here. So the question and the answer for it is predicted numbers of sequences 1, 1, 2, 3, 4. So till 144 it has done. You can see here. So to summarize or to use the text streamer, right? So if you use text streamer, you will get it more better. So from transformers, we have imported text streamer only for the output. Now you can see it's proper here. Those tags were not there. Previously tags were there. Now it's not there. So you can see here until 233 it came in. Okay. So after this, right, you can save this model. You can save this pre-trained model in the name of LoRa for local saving. So if you just run this, it's enough. You will get it saved. So it will be available here. You can see here LoRa model. You can see here in this you have the config JSON, tokenizer JSON, and everything is available here. And the outputs also whatever we have run. So for that outputs will be available here. And after this, again, we have tested with another adapter. After saving the inference, we have again asked this. Describe a tallest tower in the France. So it is saying here, you can see here, the Eiffel Tower located is the heart of France, and you can see here the information about it. So if you want, you can even change the question here. describe the Ram Mandir at India. So let me try whether it can give this data is available. It will be okay. It's in Ayodhya, in the city of Ayodhya. You can see here the Ram Mandir, also known as Ram Temple, is a sacred Hindu temple dedicated to Lord Rama and the divine being of the ancient Hindu mythology. It's located in the city of Ayodhya. So you can see here the recent launch of Ram Mandir data. So even it is having about it. Okay, you can just change the question here and ask anything, so you'll get more interesting answers out. And after this, you have auto model focus, so you can just give a try about this models if you want to. And saving the model. Finally, we are saving the model of 4-bit and LoRa adapter and 16 bits. So these are saving related tasks, so you will specifically not require them. So until here, if you have successfully run this and if you have understood the code, that's more than enough. So I hope this was interesting, guys. So I'll come up with the Llama Stack video very soon, and also I'll come up with more interesting projects on generative AI. If you want any AI projects that need to be done, production level code, then comment below production. So I'll try to make it soon. It depends on your comments. So the more you comment with the name called production, I'll come up with the videos very soon. Okay, guys. So meet you all again. Bye bye.